Welcome to the Brisbane Severe Weather Analysis for Friday, November 21st, 2025. This morning's atmospheric sounding reveals a dynamic environment with significant thunderstorm potential developing through the afternoon. Let's dive into what the atmosphere is telling us. Looking at this morning's 10 a.m. sounding, we are seeing a warm, humid air mass near the surface. The red temperature line shows 27 degrees Celsius at ground level, with the green dew point at 22 degrees. That 5-degree spread tells us the air is quite moist. The blue dashed line shows our mixed layer parcel path, which represents air from the lowest 100 hectopascals of the atmosphere. Notice how the parcel path curves to the right of the temperature profile in the upper levels. That gap represents instability, the fuel available for thunderstorms. We are measuring 1466 joules per kilogram of mixed layer CAPE, which is moderate energy. There's essentially no cap, no lid holding this energy down, which means if something triggers a storm, that energy is readily available. The wind barbs on the right show relatively light winds near the surface, about 3 meters per second from the southwest, gradually increasing and veering with height. Now let's see how this environment transforms through the afternoon. This enhanced diagram adds critical context with the pink and blue shaded areas. The pink shading represents CAPE, the positive buoyancy area where our air parcel is warmer than its surroundings. This is the fuel that powers updrafts. Notice there's no blue shading near the surface, which confirms we have no convective inhibition, no barrier preventing storms from firing. As temperatures climb to a forecast high of 29 degrees, we are expecting the surface-based CAPE to remain around 2800 joules per kilogram, while mixed-layer CAPE increases to just over 2000 joules per kilogram. The equilibrium level, marked EL, sits around 234 hectopascals, giving storms plenty of vertical depth to work with. The level of free convection, marked LFC, is quite low, meaning parcels don't need much lifting to start accelerating upward. The lifting condensation level, LCL, sits at around 942 hectopascals, or 637 meters above ground. That's a favorable height for organized storms. With moderate CAPE and moderate shear of about 11 meters per second through the 0 to 6 kilometer layer, we are looking at conditions favorable for organized multicellular thunderstorms, with a low possibility of weak supercells if shear increases slightly. Looking ahead to tomorrow morning, the machine learning forecast models paint a very different picture. The GraphCast model predicts mixed layer CAPE dropping dramatically to just 205 joules per kilogram, with surface-based CAPE at 565. That's a collapse of the instability we are seeing today. Wind shear remains around 10 meters per second, similar to today, but without sufficient CAPE, we are looking at subconvective conditions. The significant tornado parameter drops to 0.00, and the supercell composite parameter also falls to 0. Both the hail and tornado threat levels drop to none. The environment tomorrow morning simply won't have enough fuel to support organized thunderstorms. This represents a major change from today's moderately unstable air mass to tomorrow's stable, benign conditions. It's a textbook example of how quickly atmospheric conditions can shift in southeastern Queensland. The model comparison table shows us the spread in tomorrow's forecast. GraphCast predicts 1173 joules per kilogram of surface CAPE and 837 of mixed layer CAPE. Pangu is more conservative at 842 and 551 respectively. Interestingly, ForecastNet predicts 0 CAPE entirely, suggesting a completely stable atmosphere. The ensemble mean sits at 672 plus or minus 494 joules per kilogram, which is a huge uncertainty range. All three models agree on wind shear staying around 10 to 12 meters per second. This spread tells us that while all models agree tomorrow will be less unstable than today, there's significant disagreement on exactly how much energy will remain in the atmosphere. The wide uncertainty bars remind us that forecasting is probabilistic, not deterministic. The hodograph gives us crucial information about wind shear and storm rotation potential. This circular diagram shows how winds change with height, with each point representing wind direction and speed at different levels. The colored line spirals from the center outward, starting at the surface in dark purple and climbing through the atmosphere to yellow at upper levels. We are seeing a relatively straight hodograph, with winds backing slightly from southwest to more westerly with height. The 0 to 6 kilometer bulk shear measures 10.7 meters per second, which is in the marginal to moderate range. The 0 to 1 kilometer storm relative helicity is only 53 meters squared per second squared, which is quite low and not favorable for tornadoes. The 0 to 3 kilometer SRH is 167, which is better but still modest. The supercell composite parameter of 0.69 and significant tornado parameter of 0.26 both fall well below severe thresholds. The red star marked RM shows the bunker's right-moving supercell motion vector, while the blue star marked LM shows the left-moving storm motion. If supercells were to develop, they'd move toward the east-northeast. The relatively compact hodograph suggests storms are more likely to be multicellular rather than supercellular today. The atmospheric refractivity profile, also known as the N profile, shows us how radio waves and radar beams propagate through the atmosphere. The blue line represents the refractive index at different heights. Near the surface, we see very high refractivity values around 350 N units, which then decrease rapidly with height. The yellow shaded zones indicate regions where atmospheric ducting can occur. We are seeing elevated duct conditions between about 1,000–1,500 meters, and another layer around 3,000 to 5,000 meters. These ducting layers can trap radio signals, causing them to propagate much farther than normal. For radio operators, this means enhanced VHF and UHF propagation is likely this evening. For meteorologists, it indicates stable layers in the atmosphere where temperature inversions exist. These stable layers can sometimes act as lids on convection, though as we saw in the skew-t, we don't have a strong capping inversion affecting our thunderstorm potential today. To summarize, this afternoon brings moderate thunderstorm potential for Brisbane, with enough CAPE and Shear to support organized multicells and possibly a weak supercell. The primary threats are heavy rainfall and isolated strong wind gusts, with low potential for large hail and very low tornado risk. By tomorrow morning, models suggest a significant decrease in atmospheric instability. Always consult the Bureau of Meteorology for official forecasts and warnings. Stay weather aware. Brisbane. This has been your atmospheric analysis from Distant Curve.